Electric blenders generate high levels of noise when in use. Exposure to these noises in the long run may leave negative effects on the user's health and comfort. This study aims to measure and analyze the noise levels produced by 5 different blenders at 3 speed settings using Audacity and MATLAB software. From the data obtained, we found that the best blender in terms of noise level and performance is the Premier blender.
The background of this project is the demand of a better user experience for home appliances has been increasing. For instance, food blenders produce a sound level of around 85 decibel, which is considered loud as mentioned by WHO. Thus, proper planning and equipment are required to understand the sound level and the danger it poses to human health. Next, we'll talk about the problem statement for this project. The addressed issue is related to the lack of understanding about the potential health problems arising from noise levels produced by blenders at various blade speed. Some level of blender is around 85 decibel, which is considered dangerously loud after long exposure, and potentially endangers one's health and permanently damage a person's hearing and cause other health complications. The objective of this project is to study the process of capturing and measuring of sound signals produced by blenders from 5 different brands, to compare the noises produced by each blender at 3 different speeds using Audacity and MATLAB software, and to identify the most suitable blender to use for an extended period of time. The material and apparatus used in this project are microphone, laptop or PC, and also blender of different brands. And also the software used are MATLAB and Audacity.
There have been many studies and research on the impact of noise pollution on human well-being. In their 2003 research paper, Stansfeld and Matheson found that the most prevalent reaction to noise is annoyance, and this can lead to feelings of intrusion into personal privacy. Furthermore, Hiral Jariwala stated in his 2017 research paper, Noise Pollution and Human Health, a Review, that noise can impact the enjoyment of one's leisure time. This leads to adverse reactions such as anger, frustration, discontent, anxiety, distraction, and exhaustion. A 2014 study by Fisher et al. Observes that the kitchen stands out as the loudest area within a household due to their lack of sound-absorbing materials such as curtains or carpets. The primary sources of kitchen noise originate from electromotively driven kitchen appliances. Finally, a 2019 study on the indoor kitchen soundscape by Thomas et al. Found that installation sounds and operational sounds, both mechanical noises generated by blenders and ovens, contribute to the irritation and discomfort caused by noise. These studies have been instrumental in our understanding of noise pollution of blenders.
Talking about the methodology, first we had brainstorming activities. We discussed our project on WhatsApp group first. We also identified sound source, which is blender from each brand. We used gaming headphone microphone to record our blender sound source in 3 different speed levels. We also assigned tasks for project completion. As our project workflow, we had ongoing discussion for mistake prevention and mutual support. We also had regular updates on upcoming activities for project progression. We also set a due date for each and every task to avoid late work and to produce good report and presentation video. The software that we use for this project is MATLAB and Audacity. As the procedure, first of all, open Audacity, connect USB microphone to PC. Set audio setup to microphone audio for playback and recording. Choose mono recording channel. Make sure the mic is 4 cm from air outlet grade. Set Blender to low speed level. Simultaneously, click record in Audacity and Blender power button. Record 5 seconds of low level Blender noise. Save the file and export to WAV file. Repeat steps for medium and high speed level. Utilize MATLAB for sound file analysis and data extraction. Organize data in tabulated format within results sections. The figure above shows an example of noise recorded using Audacity for low speed level, which is level 1.
In design concept, first we can see the data analysis of 3 blender brands, which are Premier, Panasonic and Philips. The first column in each blender brand is oscillogram of signal graph, and the second column is frequency spectrum graph. These graphs are taken in different speed level, which is low speed, medium speed and high speed. Next is the remaining blender brands in data analysis, which is Empress and in data tabulation we divided into 2 categories. Tabulation of peak coordinate based on graph and data of signal statistics and dynamic range value. For first table, we take the data of highest peak of each brand, and for second table, we take the data of maximum value, minimum value, mean value, RMS value and dynamic range. 3 malware coding we take to get the data for data tabulation. To be mentioned, make sure to save the file in directory so that we can get the graphs and data. For those whom using online MATLAB, they need to save the files in MATLAB online draft. At low speeds, Premiere excels with high amplitude and varied noise. Panasonic and Philips offer quieter blending, while Empress and Simplus show moderate and high noise respectively. At medium speeds, Premiere, Panasonic and Philips balance functionality and noise. Empress adds diversity in noise profiles and Simplus maintains high amplitude. At high speeds, Premiere leads in noise profile. Panasonic and Simplus focus on powerful blending. Empress offers varied noise options and Philips prioritizes quiet operation. The analysis of signal statistic data and dynamics. First we see Premiere. Premiere has outstanding performance at all speeds with the high max values and a consistent dynamic range and RMS values. Secondly, Panasonic offers a balance of functionality and noise reduction at low speeds. The dynamic range is 85.047 decibel, increasing to 90.309 decibel at medium and high speeds. Philips prioritizes quieter operation with lower RMS values and a slightly smaller dynamic range compared to Premiere. Empress has a variable noise profile capable of loud sounds for certain tasks with a dynamic range that varies across speed settings. Simplus is notable for powerful blending with a high RMS values and a dynamic range of 90.309 decibel, demonstrating strong performance at different noise levels. Premiere is the top choice among blenders like Panasonic, Philips, Empress and Simplus, excelling in performance, versatility and noise balance. It outperforms others with a high efficiency and a broad dynamic range, making it suitable for various
We were
blending.
able to measure the noise levels produced by 5 blenders of different brands across 3 different speed settings. We also analyzed the noise levels produced by each blender using Audacity and MATLAB software. From this, we found that Premiere was the best blender for prolonged use in terms of noise level and performance. Panasonic and Philips blenders were able to balance noise reduction with good functionality. Lastly, Empress and Simplus blenders had higher noise intensity throughout 3 speed settings. Hence, further innovation should be carried out to improve noise level and performance produced by blenders for user comfort.